It's the classic complaint of the teenage programmer circa 1997. QBASIC is just too slow to make actual games. But if you're at a school programming club, and all you've got access to is that and Logo, you're going to have to stick with it. And so here is my teenage programming club magnum opus Velocity 2, running on an emulated version of the typical school PC in that particular educational establishment, an RM Nimbus PC 486 SX25. No, we're not going to have the Nimbus versus Acorn argument. The memories, though. This is why you always rushed your lunch, so you could get to the programming club early and grab one of the few 486 66s in the corner of the classroom before anyone else could get to them. And on the surface of it, that is our argument sorted, right? A 486, even a low-end one, can do things a lot more impressive than this. Now, the first point of complication here is that the version of QBASIC which came with DOS was intentionally hobbled compared to the ones Microsoft wanted you to pay money for. And for true performance, you therefore needed to get hold of QuickBasic 4.5 or the Basic Professional Development System and, ideally, compile an executable. With that done, the results are better but still not good, which coincidentally is a phrase that crops up in my school reports for pretty much every subject I wasn't interested in. But the question here is, how much of this is down to BASIC, and how much of this is down to me simply not being a very good programmer? So I set out to do two things. First, I would simplify and improve Velocity 2's QBASIC version to see how much performance I had left on the table nearly 10 years ago in the 1990s. Second, I would take that code and implement it as closely as possible using C to see what, if any, speed up results. Before I do anything though, I want to quantify every step of this to see how much of an improvement I make. So we're going to rip out that useless angle bracket too slow indicator and replace it with a good old frames per second counter. Well, that ain't good. My first move in the wake of this bad news is nothing to do with performance, but I'm going to take all the junk out of this. All the game modes, the screensavers, all that pointless stuff needs to go. Mostly because I don't want to spend the rest of my life slowly re-implementing it all in C. Predictably, there is no change in the frames per second with this newer, smaller codebase. I've improved memory pressure, but done nothing about the CPU pressure. But let's start addressing that with some things I knew were slow even when I wrote this. Removing the unnecessary print statement for the status bar to give gameplay advice you can probably figure out yourself. That itself nets a decent boost, and with a little rejigging of how much of the screen gets redrawn, I can only print my frames per second counter when it updates, although that's a pretty marginal gain. There's maybe a bit more to gain in avoiding unnecessary drawing and overwriting in screen areas which will never be displayed, but that's about it for the simple stuff. There is one thing, though, that I think might be a huge speed up here, and it's in the draw track function. Every time the tile changes, we go off and load a new one from disk. It is at this point I also realise every single one of these tiles is twice the size it needs to be. Array dimensioning wasn't good at it. Now, if I could keep all of these tiles in memory, it would save having to call bload multiple times during track drawing. But even having fixed the file size problem, there's 112 kilobytes of tile data here. That's more than a 16-bit segment can hold, which is just 64 kilobytes. QBASIC arrays, even multi-dimensional arrays, need to fit in a single segment. So we're out of luck there. However, QuickBASIC will allow me to declare two arrays, each holding half the tile map, and handle dealing with segmented memory access and far pointers mostly itself. I'm now outside the realm of being able to run this in classic DOS QBASIC, but I think that's fine. We know that's going to be slower, and yes, if I was going to bring this to the school programming club, I would have to do something clever with some sort of tile cache which doesn't need to load more than 64K of tiles at a time. But I want the best possible representation of what BASIC can do, not to observe every constraint I had to work under. Few little tweaks and we've gone from 1.9 to 3.5 frames per second, which is a solid improvement, while still also being utterly tragic in how badly this runs compared to how it looks. At this point though, there's something bothering me far more. Thanks to the limitations of QBASIC's put command, Velocity 2 draws a far larger area of the map than it needs to, and then draws the border over the top. So I have to know, if I set things up so I don't have this overdraw problem, will the more efficient rendering be enough to offset the penalty of having to do it all in interpreted code? No, it really will not, and I guess I'm probably going to have to explain some of this low-level graphics code, but let's save that until I do the C version. Now, admittedly, I have not particularly optimized this, and in fact it has quite a few display bugs because getting my head around EGA planar graphics was bad enough, but it is painfully slow, and if I go any further down this route I'm going to need to change my frames per second counter for a seconds per frame one. I think we might have our answer on whether QBASIC is slower. But I'm going to be as fair as possible to the old horse. And my C version is going to do the same, right beyond the edge of the window border, then draw over it again, all in slow graphics memory. Ah, yes. About that C version. My process here is going to be conceptually quite simple. I'll replicate all the QBASIC functions which Velocity 2 calls, such as line and bload and locate and all the rest. With those in place, it will then be possible to create a one-to-one translation of the game code into C, including all those suboptimal approaches like drawing nearly a whole screen of tiles only to overwrite them, all without any off-screen buffers. If anything, this is being unfair in QBASIC's favour, as it's unlikely my half-assed attempt at replicating the functions in C will be anywhere near as fast as Microsoft's programmers writing production quality code in the 1980s with an innate understanding of the hardware they were targeting. I do not have an innate understanding of the hardware I am targeting. I'm using OpenWatcom as my C compiler, which does have its own graphics library, and probably that would be the easy approach for some of the thornier graphics problems, but contemporary reports suggest this is pretty slow compared to hand-rolled code, and I kind of want to understand what's actually going on here, rather than exchange one black box for another. Understand being a perhaps optimistic description of what will actually happen. I was hoping I'd get something simple to start with, but the very first thing Velocity 2 does is screen 9 to set the 640 by 350 EGA mode, so we're straight into dealing with the graphics adapter and hardware outs. And then next up is CLS, clear screen. Already I'm starting the EGA fun and games, as I can't just write to the video memory and hope. As I mentioned when I was trying to get sprites working without the overdraw, EGA graphics are planar. What this means is rather than chunky pixels, where each byte of memory would correspond to 2 consecutive pixels in the 4-bit EGA palette, instead each byte of memory stores a single bit for 8 pixels in one plane, typically red, green, blue, and intensity with the default palette. By reading a byte from each of the 4 planes, these can be combined to give a 4-bit colour for each of the 8 pixels. One advantage of this is that even with slow onboard memory, the graphics controller could read from 4 different locations and therefore potentially 4 different memory chips at the same time, effectively quadrupling the memory throughput. It also had another advantage with the PC's 16-bit address space. At 4 bits per pixel, and therefore 2 pixels per byte, EGA's 640 by 350 mode requires 112 kilobytes for an entire screen, well beyond the 64 kilobyte address window of a single segment. But if we write a plane at a time, we only need a quarter of that, or 28 kilobytes, which fits easily into a single segment. The EGA offers a map mask register to let us indicate which plane the display memory starting at segment A000 corresponds to. Although perhaps I should say planes plural, because it adds another bonus. We can write to multiple planes at once. In this way, clearing the screen is just a case of setting this register to write every plane at once, and then writing 0 to the subsequent 28K of memory. I can even test to see whether I'm actually in the right mode and writing things by writing not 0 but 255, which will set all of the bits rather than clearing them and give me a white screen. I totally will not forget to change this back before writing all the rest of my game code. Now this might not be the fastest approach, and I'm sure there are some optimization tricks here I'll spend the rest of my life hearing about, but Velocity 2 doesn't ever use clear screen anywhere performance critical, so I can live with this. Next up, we have a call to a subroutine called CT, which sends us some text. This means needing to implement locate and print. Locate, QBASIC's command for setting where on the screen text will be printed, should be a BIOS interrupt to move the cursor position, so that's easy enough to implement. If I was smarter, I might have implemented my print function first to see if this was actually the right approach, but I'm not, so I didn't. Foreshadowing. And now we have print. Yes, C has a printf method, but without setting any additional registers, that uses text mode, which is a character and attribute map starting at segment B800. So in terms of our screen 9 equivalent, it's writing the wrong thing to the wrong area of memory. It's also pretty slow. So I ought to think about writing my own text output routine. Here I start opening up a world of horror. Because while I've reduced this as much as possible, Velocity 2 does still print text to the screen in the performance critical render loop. So I don't want to drag myself down by using the BIOS to painstakingly print each character. I want to do this quickly by writing directly to video memory, rather than calling interrupts. So all of a sudden I'm reluctantly learning a lot about that old int10h. Function 11 is the character generator routines. I can get the pointers for the character sets. Number 2 is the 8x14 EGA font. With a pointer to that, I can just copy characters from the BIOS font to the display memory. I zero the 8x14 area for each character to black, and then set the relevant planes for the current colour using the bit mask of each line of the character. It's probably not the fastest approach, but I avoid doing too many expensive hardware outs, and V2 doesn't print that much text. In fact, it prints hardly anywhere. This is a premature optimization. Don't code the way I code. With the character routine set up, locate can stop using those BIOS interrupts and become a straight manipulation of my own row and column variables. And I can also easily implement the QBASIC color statement because I'm already using a static variable for that. Yes. Thanks, I hate it. This is awful programming. Whose idea was it to do this? Before I go too much further, this was supposed to be print, which can handle entire strings and not a single character printer. But creating a wrapper function to turn it into that is a relatively easy bit. Now we hit load track tiles, and the first one I'm kind of worried about, because this uses bload to load sprites from a file on disk, and I have two things to be concerned about there. Firstly, I will need to start dabbling in allocating memory using far pointers, which I have never done before. By the time I started writing C programs which needed more than 64K of memory, I was using a protected mode compiler and flat 32-bit addressing. Secondly, beloading a sprite specifically implies I will soon need to put it on a screen somewhere, even if just to verify that my beload routine worked correctly. I am dreading the bit where this gets to graphics programming more complex than just clearing a screen or copying a character. Well, let's deal with the first of those problems. I'm going to go with a cautious approach that reads the file character by character into the pointer it's given. Printing some contents of the array seems to work, so let us skip ahead to the horror that is going to be implementing the put command, the one which takes sprites from memory and puts them on screen. Here is where this being EGA and a planar graphics mode really starts to bite. When I write a byte to a plane, I'm writing to 8 different pixels at once. And with a sprite that came from a QBASIC program, that would be fine, because QBASIC stores them with this in mind, and arranges them in planes already. So each byte there is also 8 pixels worth of bits for a single plane, and this all works fantastically. Until you consider, what if I want to put the sprites on an x-coordinate, which is not a multiple of 8? At this point, the bytes of graphics memory are not aligned to the bytes of the sprite. And so I have a range of new and exciting problems. Firstly, I need to shift the bits in each individual byte right by however many pixels I'm offset from a multiple of 8, and then carry any remainder into the next byte. But also, when it comes to the left and right edges, I need to preserve what's already on screen to prevent my sprites appearing with a border of between 1 to 7 pixels whenever they're not perfectly lined up on a boundary. Thankfully, the EGA offers a mask register, so I can latch the memory before writing, and only the pixels specified in the mask will be updated. You know, I'm starting to respect the EGA a lot more as a piece of hardware. It got a lot of things to help out programmers. At this point, as well as discovering a newfound respect for the EGA, I'm starting to get a bit more of an answer about the speed of QBASIC. When, as a teenager, I used put as a black box, I didn't understand quite how much work was going on behind the scenes to satisfy my desire to just throw an image anywhere I wanted on a planar display mode, byte alignment be damned. Now I'm getting exposed to it, and I'm realizing that, yeah, this is going to be slow. In all but the ideal situation, every plot to the screen will involve painstakingly shifting the bits in every byte, along with issuing multiple slow out instructions to the video card every row to set all those mask registers. On the plus side, slow the implementation may be, but the instruction I was dreading is now out of the way, and there are only 2 other graphics interactions needed to complete the set for Velocity 2. P-set to draw a single pixel, and line. That latter one is made easier, because most of the time Velocity 2 only draws boxes, borders and horizontal lines, so I only need to implement these simple cases, not everything the QBASIC line command can possibly do. And with that, I can start implementing a decent proportion of the game logic. Saying that, just getting far enough to replicate the please wait initializing screen is a wild ride, as I have to add all of the global variables. And there are many of them. Yes, this is not a particularly well-structured program. It's almost like I didn't really know what I was doing. And then, on top of that, I find all sorts of fun and games waiting for me with wrong-sized arrays resulting in the stack getting clobbered, and my new code crashing unexpectedly as it tries to load the track tiles. Yeah, arrays. I really was not good at these when I was younger. On the plus side, we are in a language where we have pointers now, and I no longer need to operate that weird 2-part map. Now, I said I wasn't going to optimize the code as I wanted a one-to-one mapping between the basic logic and the C logic, but this is unlikely to make a massive difference, and, you know, I think it's important for my sanity that I don't have to do that 2-part tile map in yet another language. It's not too much work from here to get the menu up and running. A couple of new basic commands I need to translate here and there, but by this point I've done most of the hard work with the EGA interfacing and can lean on what's already there. And now we can get our first performance comparison, even if it's not the main game loop. And it's interesting. The main menu is blazing fast compared to the QBASIC version. There's no more painful waiting for the track map to be drawn before you can do anything. It's just done. But the initial load is, if anything, slower. And that points to one thing. QBASIC's implementation of bload is very well optimized, whereas mine is not. I can live with this for now because I don't try to load things from disk in any performance-critical sections anymore. But I'm seeing a suggestion here that translating naively to C is not magically so much faster that I don't have to think about what I'm doing. I'm not good at thinking about what I'm doing. Anybody who's watched me for some time will know this. The rest is all just more one-to-one translation, with the occasional pause to implement some other basic command I've missed, and soon enough I've replicated the bulk of Velocity 2's graphics engine. The only thing missing is the car, and it turns out to be surprisingly hard to play the game without it. And yeah, the car. So, the way Velocity 2 handles car sprites is pretty clever. For the constraints of a largely self-taught teenager, adjust your expectations accordingly. It stores only 2 sprites on disk, one for the car facing north, and one for it facing northeast at 45 degrees. I probably did that in PaintShop Pro way back when. The game code then replaces the magenta with the correct colour for the car the player has chosen, creates all 4 rotations of each sprite, and then also creates the sprite mask used both to draw the shadow and to draw the car itself. Okay, Slightly less cleverly, it does this by drawing them to some off-screen graphics memory and then using Git to turn them back into sprites because younger me couldn't figure out the necessary manipulation in memory, and... yeah. Current age me is going to have to either implement Git, which I don't want to do, or figure out that necessary manipulation in memory to rotate them. And these are sprites designed for the EGA, split up into planes with 8 pixels worth of horizontal data in each byte. Yay! My plan of attack here is to sidestep a bunch of that complexity by converting them into chunky format, slightly wastefully using a byte per pixel to represent the half-byte sized EGA color index, do the manipulations in that much easier color space, and then convert them back into planar format. Here is where progress stalls, as creating planar to chunky and chunky to planar is a few hours of brain-bending torture until I finally have something which seems to work. A bit more hair-tearing follows as I work out how to emulate the AND and XOR modes of QBASIC's put command. Eventually I figure out that this is a function of the EGA hardware, and I just need to set the correct logical function, and it will work. Although, unlike my pset mode, I do need to read each byte before setting it to make sure the card latches data properly. By this point, I am leaning heavily on Richard F. Ferraro's Programmer's Guide to the EGA, VGA and Super VGA cards, and I think that answers one of the questions I had from my youth, which is that without that book, C might not have been too slow to make actual games, but it was definitely too complicated for me. As I add each of these features, I find I'm losing a few frames per second here and a few frames per second there, gradually eroding that performance advantage I thought I had. Now, since I don't have to do anything more that's graphically intensive, I'm hoping I can implement the skid physics function and some minor graphical niceties without losing any more, but I do fear my youthful dreams of rewriting this in C and having it be 50 times faster through the sheer magic of C alone are long gone. But with those little additions made, it's time to copy all of this across to the emulated 48625 and see the moment of truth. Remember, we're looking to beat around 3 to 3.5 frames per second on the road to nowhere track. And the answer is 4.325 frames per second. So at the bluntest level, yes, even with relatively naive implementations of all the functions, C is faster than QBASIC. 40% is a not inconsiderable speed boost, and in this instance, on this machine, it turns Velocity 2 from unplayable to playable, I guess, if you're being charitable. But hang on, this is a 48625. It's low in the 486 hierarchy, but it's still a computer capable of fairly credibly playing Doom, if you apply mid-90s standards of credibly, or at least accept it's clearly playing Doom more credibly than I am in this footage. Why is a simple EGA game that looks ancient in comparison giving it so much trouble? Well, part of that is the bounds I set for the exercise. I could have taken the advice every contemporary article I read about graphics programming gave and gone into assembly language for some of those graphics functions. But while that would have been faster, a look at the disassembly of my C version says I'm not giving up that much performance. Certainly not enough to boost this to 30 frames per second. So what is happening? Velocity 2 simply makes too many writes to the screen using too many slow out instructions where it's constantly having to stop and tell the EGA something else. Because the sprites are rarely aligned on pixel boundaries, it's constantly having to do calculations to display them, rather than simple memory copies as would be the case if I were doing aligned copies and using the EGA scroll register to scroll the screen, or storing pre-shifted versions in memory. And half the time all that hard work is for nothing, as it's immediately covered up because we don't want a sprite to display in that location. I could end there, and I'm sure the vanishingly tiny number of people who've been patient enough to get to this point but not that patient would like me to. But I'm not. Let's go back to that failed attempt at optimization of the basic version, where I tried to clip the drawing area so I didn't have to draw so much and overwrite so much, and this time do it in C. We're now up to 6 to 7 frames per second. I'm not saying that's good for a game which looks like this, especially not on a 486/25, but compare that to the horrors of what happened when I converted the QBASIC version to put clipped. This is the real performance problem with QBASIC. The built-in functions like bload, put, line and all the others are well optimized, and if you can surround them with the minimum of interpreted code, you can get decent performance out of it. Velocity 2 still worked well on a faster 486 or Pentium, and while that's an utterly silly minimum spec, it was still something which looked impressive when you brought it up in a school programming club where everyone else was limited to the same tools you were, especially if you'd grabbed the fast 486. But that's the problem. You're limited to what the tools can do. Put can't clip its sprites, so if you want a scrolling display like this one you have to draw, then overdraw. Sure, you can write what you want yourself, but then you have to do it in interpreted code, and that is slow. I'm still not sure I agree entirely with that sentiment of the teenage programmer circa 1997. We've seen from reimplementing Velocity 2 in C that bad approaches are slow, whatever the language, and a 40% speedup isn't going to get you out of a situation where what you were doing was just too slow to begin with. Which also gives the inverse result. By using the library functions effectively and paying attention to minimizing interpreted code in tight loops, it is possible to write playable and fun games in QBASIC. Perhaps even more so today, when the gap between what you can get out of it and what commercial games of the time were doing is nowhere near as big as the gap between pretty much anything from the period and modern gaming. And those simple high-resolution EGA modes now have their own retro charm. Indeed, I have done exactly that in previous videos, where I upgraded some of my old programs with new features and capabilities. What it's not possible to do is write any sort of game you feel like, unless you are so knowledgeable and comfortable with doing things like cramming in your own assembly language routines that you may as well be writing them in C and assembler anyway. And that's the thing. Would I have been able to write much better games by switching to C? No. Because I was not that talented a programmer, and I did not have access to that many reference materials. The amount of pain it's taken me to get just what I wrote originally running as a C program suggests I'm not a talented enough programmer now either. And please don't tell my employers that. Games in this era were feats of optimization and hardware trickery, and anything involving the EGA was another level of knowing the hardware inside out and every trick which could be performed with write modes and registers to minimize the amount of data which needed to be sent over the slow ISA bus. I'm no longer bemoaning my programming language. I'm bemoaning my lack of knowledge of this hardware. Of course, back in the late 90s, I did eventually start writing games in C. But it was with the help of libraries such as Allegro, and then, once 3D accelerators became common, SDL and OpenGL. Those games were indeed faster and more impressive, everything I had hoped for from the change in language, but only because someone else had already done the hard work for me. Am I disappointed that I put in all this effort and the result was 7 frames per second? You know, actually not. The result is playable, even if that statement is orbiting the gravity well of technically correct is the best kind of correct closely enough to be in danger of controlled flight into terrain. But also there's a whole new challenge here. A tangent I constantly had to stop myself from disappearing down while trying to make a one-to-one translation of my original code. If I abandon that, it should work like the QBASIC version constraint, and go hard into optimizing this code. How far can I go? How fast could it be? I would be keen to hear any thoughts from those of you who know this territory well, because even if they all conflict, I am absolutely down for making a narratively unsatisfying video full of distractions and dead ends which don't go anywhere. Again, and join me for that at some unspecified point. Or don't, I'm not your mum, unless there's been a horrific time travel accident at some point in the future. I'm not counting that out, 2026 is a time.